Hello students, welcome to the math class. Today we are going to discuss about chapter 7, that is triangles. You have studied about triangles and their various properties in your earlier classes. You know that a closed figure formed by the intersecting lines is called triangle. So students, as you can clearly see, line L, line M and line N, they are intersecting each other. Line L and line M are intersecting each other at point A. Same way, line M and line N, they are intersecting each other at point B. Same way, line L and line N, they are intersecting at point C, thereby creating an enclosed plane surface, that is the surface bounded by these three lines, and thereby forming a triangle ABC. So, as we know that a part of line is the line segment having certain measurement. So, in this case, this triangle has three line segments, or we can say three sides AB, BC and AC. And the point of intersection of the lines, those are point A, point B, point C, are called the vertices of the triangle. A, B and C, they are the vertices. So, at every vertex, the triangle is forming three different angles. Those are angle ABC at vertex B, angle BAC at vertex A and angle ACB at vertex C. So, these are the basic concepts of a triangle. What are those? A triangle is an enclosed surface that is created by the intersection of three different lines. Thereby, the triangle has three different sides AB, BC and AC, as you can clearly see here. It has three vertices A, B, C, which are nothing but the point of intersection, and at each vertex the triangle is creating three different angles, angle ABC, angle BAC and angle ACB. So, these are the basic concepts of a triangle. Okay. Now, we will discuss about the congruence of triangles, rules of congruence, some more properties of triangles and inequalities in a triangle. So, students, let us discuss congruence of triangles. As it is given in your book, you must have observed that two copies of your photographs of the same size are identical. Similarly, two bangles of the same size, two ATM cards issued by the same bank are identical. You may recall that on placing a 1 rupee coin on another minted in the same year, they cover each other completely. This is called congruency, because all these items are called congruent items. Let it be 1 rupee coin, let it be 100 rupee note, let it be ATM cards of a single bank. Every single item is similar in shape and size. That's why they are called congruent items or congruent objects, because they exactly cover each other. In case of triangles, we have also some properties which can verify that the triangles are congruent. Let us discuss those properties. Now students, as it is given in your book, draw two circles of the same radius and place one on the other. What do you observe? They cover each other completely and we call them as congruent circles. Okay? Now, you can repeat this activity by placing one square on the other with sides of the same measure, or by placing two equilateral triangles of equal sides on each other. You will observe that the squares are congruent to each other and so are the equilateral triangles. You may wonder why we are studying congruence. You all must have seen the ice tray in your refrigerator. Observe that the molds for making ice are all congruent. The cast used for molding in the tray also has congruent depressions. So, whenever identical objects have to be produced, the concept of congruence is used in making the cast. Sometimes you may find it difficult to replace the refill in your pen by a new one, and this is so when the new refill is not of the same size as the one you want to remove. Obviously, if the two refills are identical or congruent, the new refill fits. So you can find numerous examples where congruence of objects is applied in our daily life, isn't it? Okay students, can you think of some more example of congruent figures? Now as given in your book, which of the following figures are not congruent to the square in figure 7.3 bit 1? Let's observe. See, you have a square and you can clearly observe that the last square of the series, okay, the last square of the series is of exactly same shape and size. That means if we place these two squares one on another, then they will cover themselves exactly. You will feel as if there is a single square rather than two squares, because the squares are covering each other completely, isn't it? Now let us discuss congruency of some triangles. As given in your book, we have some triangles, okay, and they have some sides. The measurement of the sides are written over there. So what you feel, whether all the triangles are congruent? Because you can observe that many of the triangles have the same sides, but are they congruent? Let us think about it. The first triangle, it has side 4.5 centimeter, 4 centimeter and 5 centimeter. Same as the next triangle, it has also the sides 4 centimeter, 5 centimeter or 4.5 centimeter. Same goes with figure 3 and figure 4. What about figure 5? It is having sides of 5 centimeter each. So the fifth triangle is the odd one out, isn't it? But whether all the four figures are congruent? If I rotate the triangle that is in figure 2, so what we see that the vertex P goes upward and the base RQ comes downward. That means this is the triangle ABC having 4.5 centimeter, okay, 4 centimeter and 5 centimeter of sides, and some signs are given like this. I will explain what this means. So students, let us concentrate on triangle number 2. It is PQR. Let us rotate it upside down. The present position of the triangle is like this. Okay, this is P, Q and R. If I rotate it upside down, this gives us triangle PQR. Okay, triangle PQR. So what is the measurement of side PQ? It is 4.5 centimeter. What is the measurement of side PR? It is 4 centimeter. And what is the measurement of side QR? It is 5 centimeter. So what we observe that AB is equal to PQ, AC is equal to PR, BC is equal to QR. That means the sides are equal to each other, okay. And what about the angles? Angle B, here in this triangle, second triangle, angle Q is denoted like this, angle P is denoted like this, angle R is denoted like this. What this shows This shows that angle B is equal to angle Q because both the angles have same number of curves. Angle A is equal to angle P and same as angle C is equal to angle R. That means these two triangles are congruent. Now if I put one triangle over another, I can feel as if they are single triangle rather than two triangles because they will exactly or completely cover each other. Okay? So students, this is figure 3. The triangle DEF. If I rotate it anticlockwise and keep the base of the triangle as DE, it will have a look like this. Okay? D, E and F. Fine? So let us write down the measurements first. D is of 5 centimeter. EF is of 4 centimeter and DF is of 4.5 centimeter. So now you can clearly see that AB is equal to DF, AC is equal to EF and BC is equal to DE. So the corresponding sides of the triangle are equal. Same way the corresponding angles, angle A is equal to angle F, angle B is equal to angle D, angle C is equal to angle E. So these two triangles are also congruent to each other. Okay? Let us see what happens with triangle number 4. So students, if I rotate this triangle clockwise so that the base of the triangle becomes NR with the vertex M at the top of the triangle, so we will have the triangle like this. So this is your M, N and R. Okay? So Rn is 5 centimeter, Mn is 4 centimeter and Rm is 4.5 centimeter. So you can clearly observe that the corresponding sides and the corresponding angles are equal to each other. That means these two triangles are also congruent to each other. So what we have observed from all the given figures, the first 4 figures are congruent triangles. The 5th figure is not congruent because it has equal sides. That means it is an equilateral triangle which is not congruent to figure number 1. Okay? So students, let us compare the triangles, triangle ABC and PQR. Okay? We have come to a conclusion that these two triangles are congruent to each other. So how can we represent? We can use the sign of congruency, which is this one. Okay? So I can write triangle ABC is congruent to triangle PQR. Or I can as well write that angle PQR is congruent to triangle ABC. But we need to keep it in mind that we cannot change the sequence of the naming of the triangles. We can clearly see that ABC and PQ are congruent to each other. That means side AB is congruent to side PQ, side BC is congruent to side QR and side SE is congruent to side PR. That means they are exactly equal to each other. Same way, the angles those are formed at vertex A is equal to angle that is formed at vertex P. Angle that is formed at vertex B is equal to angle that is formed at vertex Q. Angle that is formed at vertex C exactly equal to that angle which is formed at vertex R. So we have to maintain this sequence. We have to maintain this sequence. That means we can say that these are corresponding sides and corresponding angles. Okay. So in this case, A corresponds to P, B corresponds to Q and C corresponds to R. So if I change the sequence, the representation of congruency will be wrong. That means if I write triangle QPR is congruent to triangle ABC, then this is not the right way to represent congruency, because now according to this representation, Q is corresponding to A, P is corresponding to B and R is corresponding to C, which is absolutely wrong. So we have to maintain the sequence to represent the congruency perfectly. Okay. So students, as we have observed the congruency of triangle ABC and PQR, you can also observe the congruency of triangle ABC and triangle DEF, and you can also find out the corresponding sides, corresponding vertex and corresponding angles of those two triangles. So from that you can come to the conclusion that triangle FDE is congruent to triangle ABC, but writing triangle DEF congruent to triangle ABC is not correct. Okay. So it is necessary to write the correspondence of vertices correctly for writing the congruence of triangle in symbolic form. Note that in congruent triangles, corresponding parts are equal and we write in short CPCT for corresponding parts of congruent triangles. Okay. Students, as given in your book, draw two triangles with one side 3 cm. Are these triangles congruent? Observe that they are not congruent. Let us check it out. Okay. It is given that two triangles ABC and DEF. What about the base side? Side BC and side EF. BC is having measurement 2.4 cm and EF is measuring 3 cm. So if I name the triangles are triangle ABC and triangle DEF, that means for congruency AB should correspond to DE, BC should correspond to EF and AC should correspond to DF. But in this case BC is not corresponding to EF, they are of different measurement. That is why triangle ABC is not congruent to triangle DEF. Now draw two triangles with one side 4 cm and one angle 50 degree. Are they congruent? Let us check it out. As you can clearly see that if I name the triangles as triangle ABC and triangle PQR, AB should correspond to PQ, BC corresponds to QR and AC to PR. In this case BC is corresponding to QR because both are having side 4 cm. We do not have the value of AB, AC, PQ and PR. We have an included angle between AB and BC which is equal to the included angle between PQ and QR, that is 50 degree. That means vertex B also corresponds to vertex Q. But we can clearly see that PQ is greater than AB and PR is greater than AC. So they are not corresponding to each other. That means though these two triangles have a common side and a common angle, they are not congruent, because for congruency all the corresponding sides and corresponding angles should be equal to each other. Okay? So we can say that triangle ABC is not congruent to triangle PQR. Let us check it out for another pair of triangles. Okay? So as given in your book, we have a pair of triangles, triangle ABC and triangle PQR. In this case, AB is corresponding to PQ because they have equal value of 2 cm. BC is the corresponding side of QR having equal measurement of 4 cm. And the included angle, that means that angle between side AB and BC, that is 50 degree, and in the same way the included angle, that is angle between PQ and QR, is 50 degree. That means we have two equal sides and the included angle is also equal in both the triangles. So we can say that these two triangles are congruent to each other. This is the first criterion for congruence of triangles. So this gives us the axiom 7.1, that is SAS congruence rule. What does it mean? SAS, side, angle and side. That means in two triangles, if two corresponding triangles are equal and they have equal angle included within themselves, then those two triangles are congruent to each other. Okay? This is called your SAS congruence rule. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. This result cannot be proved with the help of previously known results, and so it is accepted true as an axiom. Let us now take some examples. Okay? Students, you can observe the diagram on your book or you can watch here. Okay? So the question says that in this diagram, OA is equal to OB, OA is equal to OB and OC is equal to OD. And it asks that to prove triangle AOD is congruent to triangle BOC. Okay? In the first case, we have to prove that triangle AOD is congruent to triangle BOC, and hence we need to prove that AD is parallel to BC. So let us prove the first bit first, that is we need to prove triangle AOD is congruent to triangle BOC. Okay? So students, in your question, OA is equal to OB, OA is equal to OB and OC is equal to OD. These are given data, isn't it? These are given data. Also, you can clearly see that angle COB and angle AOD, that is angle BOC and angle AOD. They are equal to each other. Why? Because they are vertically opposite angle. We know that vertically opposite angles are equal to each other. So, angle BOC is equal to angle AOD. Why? Vertically opposite angles. So, what we have found out here that these two triangles have two sides which are corresponding and equal, and another pair of sides they are also corresponding and equal, and the included angle between these two sides are equal as well. So, they are following the SAS congruence rule. So, finally, we can write that triangle AOD is congruent to triangle BOC by SAS congruence rule. Fine. So, in this way we have proved that triangle AOD is congruent to triangle BOC. So, let us go for the second bit. So, we need to prove that AD is parallel to BC. Okay? AD is parallel to BC. So, to prove AD is parallel to BC. Up to now we have proved that triangle AOD is congruent to triangle BOC. So, in case of congruent triangle, the other corresponding parts are also equal, isn't it? So, in this way we can say that angle OBC is equal to angle OAD because they are corresponding angles. And one thing we know that from the concept of parallel line and transversal, interior alternate angles, isn't it? So, whenever two interior alternate angles are equal, the lines intersected by the transversal has to be parallel. So, there is the line BC and AD. These two line segments are being intersected by line AB at point B and A. So, thereby they are forming two interior alternate angles, angle OBC and angle OAD. From the congruent triangles, we have found out that angle OBC is equal to angle OAD. That means as the interior alternate angles are equal, BC is parallel to AD. Okay? This is proved from the concept of parallel line and transversal. Okay? So, we have proved that AD is parallel to BC. Clear? This ends your example 1. Students, this is it for this session. Up to now, we have gone through the concepts of congruency, the first rule of congruency, that is SAS, and example 1. We have many more concepts to learn in this chapter, and we will cover all the concepts in the upcoming classes. Hope you have understood the concept that we have discussed in this class. Revise it very well and keep practicing. So, we will meet in our next class and continue with this chapter. Okay then? Thank you.